An electrical hazard incident occurred. The incident description is as follows. A service technician's helper and his leadman were performing service work when they encountered an electrical hazard. They were informed that framers working nearby were experiencing electrical shocks. Upon investigation, the helper attached the number 4 ground wire connected to the ground rod and received a severe electrical shock. The investigation findings showed that the leadman witnessed the incident and described the helper's reaction. Subsequent investigation revealed that the problem originated in the utility meter. The hot wire had been incorrectly connected to the neutral lug in the meter. This error caused the neutral wire to become energized, creating a dangerous situation. Lessons learned include always testing before touching. The helper's first instinct was to touch the ground wire before testing it. Always test electrical components before touching them, even if you believe they are safe. Be aware of potential hazards. In this case, the helper was unfamiliar with the potentially hazardous situation created by the incorrect wiring in the meter. It is essential for electricians and their helpers to stay informed about potential electrical hazards and take appropriate precautions. Communicate clearly. The construction manager played a crucial role in alerting the electricians to the electrical shocks being experienced by the framers. Clear communication is vital in preventing electrical accidents. Hold utilities accountable. The utility company was responsible for the incorrect wiring in the meter. It is important to hold utilities accountable for their actions and ensure that electrical systems are installed and maintained safely. Recommendations include that utility companies should implement strict quality control measures to prevent incorrect wiring in meters. Electricians should always test electrical components before touching them. All electrical workers should receive thorough training on electrical safety. Construction managers should be vigilant in reporting potential electrical hazards. Testing electrical components is crucial for safety. Prior to touching any electrical wire or component, always use a properly calibrated and functioning electrical tester to verify whether the wire or component is energized. This includes using a multimeter or non-contact voltage tester to check for the presence of voltage. Ground wires should never be assumed to be safe. Even if a wire is designated as a ground wire, it can become energized under certain fault conditions, such as the one described in the incident. Always test ground wires before touching them to ensure they are properly grounded and not carrying any current. Stay informed about potential hazards. Electrical systems can be complex and potentially dangerous. Stay up to date on the latest electrical codes, safety standards, and potential hazards. Attend training courses, read industry publications, and consult with experienced electricians to expand your knowledge and skills. Grounding systems play a vital role in electrical safety by providing a low impedance path for fault current to return to the source. This helps to trip circuit breakers or fuses, quickly disconnecting the power and preventing electrical shocks or fires. Improperly installed or maintained grounding systems can create dangerous situations. If you are not qualified to work on electrical systems, always call a licensed electrician to perform the work. Electrical work can be dangerous, and it is important to have the proper training, experience, and tools to do the job safely. Never attempt to repair or modify electrical systems unless you are qualified to do so. Follow lockout-tagout procedures. Before working on any electrical equipment, always follow lockout-tagout procedures to ensure that the power is turned off and cannot be accidentally turned back on. This involves disconnecting the power source, locking out the disconnect switch, and tagging the switch to warn others not to turn it on. Use personal protective equipment. When working with electricity, always wear appropriate personal protective equipment, including safety glasses, rubber gloves, and insulated tools. This equipment can help to protect you from electrical shocks, burns, and other injuries. Maintain a safe work environment. Keep your work area clean and free of clutter. Ensure that there is adequate lighting and ventilation. Avoid working in wet or damp conditions, as this can increase the risk of electrical shock. Report any electrical hazards immediately. If you see any electrical hazards, such as damaged wires, exposed connections, or sparking equipment, report them to your supervisor or safety manager immediately. Do not attempt to repair the hazards yourself unless you are qualified to do so. Utility companies are responsible for maintaining the electrical grid and ensuring that it is safe and reliable. This includes ensuring that meters are properly wired, transformers are properly grounded, and power lines are properly maintained. If you notice any problems with the electrical grid, such as down power lines or flickering lights, report them to the utility company immediately. Regular inspections of electrical systems are crucial for identifying potential hazards and preventing electrical accidents. Electrical systems should be inspected by a qualified electrician on a regular basis, typically every 1 to 3 years. The inspection should include a visual examination of all electrical components, as well as testing of grounding systems, circuit breakers, and other safety devices. Training on electrical safety is essential for all electrical workers, as well as for anyone who works near electrical equipment. Training should cover topics such as electrical hazards, safe work practices, lockout-tagout procedures, and the proper use of personal protective equipment. Communication is key to preventing electrical accidents. If you see someone working on electrical equipment in an unsafe manner, speak up and let them know. Report any potential hazards to your supervisor or safety manager. And if you are ever unsure about how to do something safely, ask for help. Electrical codes and standards are designed to protect people and property from electrical hazards. These codes and standards are developed by organizations such as the National Electrical Code, the Institute of Electrical and Electronics Engineers, and Underwriters Laboratories. Electrical workers should be familiar with the electrical codes and standards that apply to their work. Quality control measures are essential for preventing electrical errors. Utility companies should implement strict quality control measures to ensure that meters are properly wired, transformers are properly grounded, and power lines are properly maintained. Electrical contractors should implement quality control measures to ensure that electrical systems are installed and maintained in accordance with electrical codes and standards. Vigilance is key to preventing electrical accidents. Construction managers should be vigilant in reporting potential electrical hazards. Electrical workers should be vigilant in identifying and correcting electrical hazards. And everyone should be vigilant in promoting electrical safety. The utility company's AIMS wiring the meter highlights the critical importance of quality control and adherence to established procedures in all aspects of electrical work. Steps to prevent similar incidents include, firstly, enhanced training programs. Comprehensive training programs for utility personnel should emphasize the importance of proper meter wiring and the potential consequences of errors. These programs should include hands-on training and simulations to reinforce correct wiring techniques. Secondly, redundant verification processes. Implement a system of redundant verification to ensure that meter wiring is checked by multiple qualified individuals before the meter is energized. This could involve a second technician independently verifying the wiring connections or the use of automated testing equipment. Thirdly, standardized procedures and documentation. Develop and enforce standardized procedures for meter wiring, including detailed diagrams and checklists. Ensure that all technicians are thoroughly familiar with these procedures and that they are consistently followed. Fourthly, independent audits. Conduct periodic independent audits of meter wiring practices to identify potential weaknesses in the system and ensure that procedures are being followed correctly. Fifthly, root cause analysis. When an error occurs, conduct a thorough root cause analysis to identify the underlying factors that contributed to the error. Use this information to develop corrective actions to prevent similar errors from happening again. Sixthly, technology solutions. Explore the use of technology solutions, such as automated wiring verification systems to reduce the risk of human error. Seventhly, communication and feedback. Foster a culture of open communication and feedback, where technicians feel comfortable reporting potential problems or suggesting improvements to procedures. Eighthly, collaboration with industry experts. Collaborate with industry experts and other utility companies to share best practices and learn from their experiences. Ninthly, continuous improvement. Implement a system of continuous improvement to identify and address potential weaknesses in meter wiring practices. 10thly, public awareness campaigns. Launch public awareness campaigns to educate homeowners and businesses about the dangers of tampering with electrical meters and the importance of reporting any suspected problems to the utility company. Electrical safety is a shared responsibility. By working together, we can create a safer environment for everyone. The incident also underscores the need for electricians to prioritize safety at all times, even when performing routine tasks. Key steps for electricians to take include: firstly, always test before touching. Use a properly calibrated and functioning electrical tester to verify that all wires and components are energized before touching them, even if they appear to be safe. Secondly, wear appropriate personal protective equipment. Wear appropriate personal protective equipment, such as rubber gloves, safety glasses, and insulated tools to protect yourself from electrical shocks and burns. Thirdly, follow lockout-tagout procedures. Follow lockout-tagout procedures to ensure that the power is turned off and cannot be accidentally turned back on while you are working on electrical equipment. Fourthly, be aware of your surroundings. Pay attention to your surroundings and be aware of potential hazards, such as wet conditions, overhead power lines, and other electrical equipment. Fifthly, communicate with others. Communicate with other workers to ensure that everyone is aware of the potential hazards and is working safely. Sixthly, never work alone. Avoid working alone on electrical equipment, especially in potentially dangerous situations. Seventhly, stay up to date on electrical codes and standards. Stay up to date on the latest electrical codes and standards and follow them carefully. Eighthly, attend training courses. Attend training courses to learn about electrical safety and best practices. Ninthly, report any potential hazards. Report any potential hazards to your supervisor or safety manager immediately. 10thly, take your time. Do not rush when working on electrical equipment. Take your time and focus on the task at hand to avoid making mistakes. Electrical shock can result in serious injuries or death. Always take precautions to protect yourself from electrical hazards. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation and maintenance. Compliance with the NEC helps to minimize the risk of electrical shocks, fires, and other hazards. Some relevant NEC articles include Article 110.3, Examination, Identification, Installation, and Use of Equipment. This section emphasizes the importance of using electrical equipment that is properly evaluated and installed according to its listing and labeling. It requires equipment to be installed and used in accordance with the manufacturer's instructions. Article 250 covers grounding and bonding, which are critical for electrical safety. It requires grounding systems to be installed to provide a low impedance path for fault current to return to the source, thereby minimizing the risk of electrical shock. Article 300.4, Protection against physical damage, addresses the need to protect electrical wiring from physical damage. It specifies methods for protecting wiring from nails, screws, and other objects that could penetrate the insulation and cause a short circuit. Article 310.15, Ampacity of conductors, covers the ampacity of conductors, which is the maximum current a conductor can carry continuously without exceeding its temperature rating. It provides tables and formulas for determining the ampacity of conductors based on their size, insulation type, and installation conditions. Article 408, Switchboards, switchgear, and panel boards, covers the installation and wiring of switchboards, switchgear, and panel boards. It specifies requirements for overcurrent protection, grounding, and bonding. Article 430, Motors, motor circuits, and controllers, covers the installation and wiring of motors, motor circuits, and controllers. It specifies requirements for motor overcurrent protection, motor overload protection, and motor control circuits. Article 440, Air conditioning and refrigerating equipment, covers the installation and wiring of air conditioning and refrigerating equipment. It specifies requirements for disconnecting means, overcurrent protection, and grounding. Article 500, hazardous classified locations, covers the installation and wiring of electrical equipment in hazardous classified locations, such as areas where flammable gases or vapors are present. It specifies requirements for explosion-proof equipment, intrinsically safe circuits, and other safety measures. Article 600, electric signs and outline lighting, covers the installation and wiring of electric signs and outline lighting. It specifies requirements for disconnecting means, overcurrent protection, and grounding. Article 700, emergency systems, covers the installation and wiring of emergency systems, such as emergency lighting and fire alarm systems. It specifies requirements for power sources, transfer switches, and circuit protection. Regular review of the NEC is important for staying current with the latest safety requirements and best practices. Training courses, industry publications, and online resources can help electrical workers stay up to date on the NEC. Understanding the NEC is essential for ensuring the safe installation and maintenance of electrical systems. By following the NEC, electrical workers can help to minimize the risk of electrical shocks, fires, and other hazards. The potential for backfeeding in electrical systems poses a significant hazard. Backfeeding occurs when electrical power flows in the opposite direction than intended, typically from a source within a building back onto the utility grid. This can energize circuits that are supposed to be de-energized, creating a serious risk of electrical shock or equipment damage. Sources of backfeeding include generators, solar photovoltaic or photovoltaic systems, and uninterruptible power supplies, or UPS. When a generator is connected to a building's electrical system, it is essential to use a transfer switch to isolate the building from the utility grid. Without the transfer switch, the generator can backfeed power onto the grid, potentially energizing utility lines and posing a hazard to line workers. Solar photovoltaic systems can also backfeed power onto the grid when they generate more electricity than the building consumes. This excess power is typically sold back to the utility company through a net metering agreement. However, if the system is not properly installed or maintained, it can backfeed power onto the grid even when it is not intended to do so. UPS devices are designed to provide backup power to critical equipment during power outages. However, if the UPS is not properly installed or maintained, it can backfeed power onto the grid, potentially energizing circuits that are supposed to be de-energized. To prevent backfeeding, it is essential to use the transfer switch when connecting a generator to a building's electrical system. The transfer switch isolates the building from the utility grid, preventing power from flowing back onto the grid. Properly install and maintain solar photovoltaic systems. Solar photovoltaic systems should be installed and maintained by qualified professionals. The system should be designed to prevent backfeeding and should be inspected regularly to ensure that it is operating safely. Ensure that UPS devices are properly installed and maintained. UPS devices should be installed and maintained by qualified professionals. The devices should be inspected regularly to ensure that they are operating safely and are not backfeeding power onto the grid. Install backfeed protection devices. Backfeed protection devices, such as anti-islanding inverters, can be installed to prevent backfeeding. These devices automatically disconnect the power source from the grid if a backfeeding condition is detected. Educate electrical workers and homeowners about the dangers of backfeeding. Electrical workers and homeowners should be educated about the dangers of backfeeding and the steps they can take to prevent it. This includes providing training on the proper installation and maintenance of generators, solar photovoltaic systems, and UPS devices. Communicate with the utility company. If you are planning to install a generator, solar photovoltaic system, or UPS device, contact the utility company to discuss the requirements for connecting to the grid. The utility company may require you to install backfeed protection devices or to meet other safety requirements. Backfeeding is a serious electrical hazard that can result in electrical shocks, fires, and equipment damage. By taking the necessary precautions, you can help to prevent backfeeding and protect yourself and others from harm. Assuming a 120-volt system, here are some example calculations. Calculating current. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. If you know the voltage and resistance, you can calculate the current. For example, if you have a 120 volt circuit with a 10 ohms resistor, the current would be 12 amps. Current equals volts divided by resistance, or amps equals volts divided by ohms. 120 volts divided by 10 ohms equals 12 amps. Calculating voltage. If you know the current and resistance, you can calculate the voltage. For example, if you have a circuit with a 5 amps current and a 20 ohms resistor, the voltage would be 100 volts. Voltage equals current times resistance, or volts equals amps times ohms. 5 amps times 20 ohms equals 100 volts. Calculating resistance. If you know the voltage and current, you can calculate the resistance. For example, if you have a 120 volt circuit with a 6 amps current, the resistance would be 20 ohms. Resistance equals voltage divided by current, or ohms equals volts divided by amps. 120 volts divided by 6 amps equals 20 ohms. Calculating power. Power is the rate at which electrical energy is transferred. It is measured in watts. Power equals voltage times current, or watts equals volts times amps. For example, if you have a 120 volt circuit with a 10 amps current, the power would be 1200 watts. 120 volts times 10 amps equals 1200 watts. Calculating energy. Electrical energy is the amount of electrical power used over a period of time. It is measured in kilowatt hours. Energy equals power times time, or kilowatt hours equals watts times hours divided by 1000. For example, if you use a 100 watts light bulb for 10 hours, the energy used would be 1 kilowatt hour. 100 watts times 10 hours divided by 1000 equals 1 kilowatt hour. Understanding these basic calculations can help you to troubleshoot electrical problems and to design safe and efficient electrical systems. The information provided in this narration is for informational purposes only and should not be considered as professional advice. Always consult with a qualified electrician for any electrical work.